starting. I think the audio levels are a bit on the low side. Oh. Okay. Mixer. That is all the way up. Let's do a sound check. Ooh, that sounds good. All right. I think audio is actually usable. Yay. 30 FPS. Need to do some settings. No. Yeah. Capes. Good. Does that work on my computer? 1080p. Sufficient. All right. Oh, what do I want to work on today? So this is the Lusty Lavender development server. Anyone can join. Information is here. I can put that in the description. I can also connect to the dedicated generator server. It's guaranteed to be low quality, but by low quality I mean low FPS. TPS here is 20, not bad. So last night I was working on this simple generator here, but I didn't have audio on, so it's kind of I didn't actually get it spinning. Well, basic layout, we have gas turbines here. We have generators at this end. We have a starter. And this right here just grabs the speed and makes it available to this control here. And I can add more control circuitry if I want. And this is an emergency brake, basically if I need to stop it for some reason, or if it goes over speed based on this. So if it's going over 950, it's going to slow the axle down. If it's at 970, it's going to really apply some braking power, and that can stop it while the gas turbines are going, which is pretty good. And I already did that once, and the condition's still new, so they're not bad. Not bad there. This right here, basically, when this thing gets up to 800 rad per second, it will engage this clutch, will apply these flywheels, and then you turn on this switch to lock it. Since it's not started, I don't want it rotating. This right here, basically, if I want to stop the flywheels and change out the size of the flywheels, I can stop it using this, remove the flywheels, attach new flywheels, put this back together, and then start it up again in real time. And the rest of these are pretty simple. So this right here is a current limiting circuit. It's got 2 amp cutoff, and when it hits that, it'll open these breakers, or when this switch is open. Over here, it's pretty simple as well. It's just 2 amp cutoffs. If this section here is putting more than 2 amps through, it'll stop it. And copper cable in these inductors to just enough inductance to prevent it from blowing the cable if there's a short circuit condition. This thing will catch it because it'll cause like a ramp, and I can show you what that looks like with in a more controlled way maybe later. And over here we have a test loader. This whole thing is connected, and it's kind of weird because the starter is on a separate circuit, but this one right here runs from those generators over there, pops over here, and then runs into, this is a cool thing, I'll come back to it, but basically it handles converting voltages and making it more stable. So over here we'll see the the effort percentages of what I called it. Yeah, right, I'll come back to this later. Basically we want to get this thing rolling. I think the problem I had last night was that there was low voltage on this side. Oh, it's definitely not low now. This one has, oh, that's because, ooh. These are the starters. They need at least 3 when starting. These, I feel like 3 is a bit low for these. I might want to put like 19. We'll do a better curve. Technically the config copy tool should be able to do these, but it hasn't been working to my dismay. There's a bug with the items go in, but they don't refresh the state of the thing, so it's kind of buggy, and you may have seen that last night. I hit one of those bugs. But if you do it by hand, it works fine. It updates properly. So that's that. Try starting. Right now, it's configured to go up to around 3.4 kV, and only 30% power at maximum. So right now it's 15 volts, which is 30% of 50. These won't actually kick in until around 630 rad per second. So we're going to have to wait for these to pull it up to speed. In the meantime, I'll go over this. I also have another generator over here which has been kind of just keeping things rolling, and I'll talk about how this one works too. But we'll talk about this here. I need to lower that. No. So here we have the input side, and then we have the output side. So on the input side, we have power inductors, which once I got this up to speed, I took the cables out because I didn't need it. This thing here limits the current to 3 amps at maximum. And this uses a low-pass filter, which is kind of cool, to detect how much load is on the system based on the pulse rate of this wire here. So the more this wire is on than off, the more power it's using. Yeah, what was I doing here? So this gets the voltage from this generator here, steps it the way the rest of them would be stepped on the output, gets the voltage, and then it goes into this, which basically, if the voltage is low, turn it on to the amount of power specified by this button, which is 50 volts. You could change it to change the amount of power it puts in, but these are just relays, so it wouldn't really do much. And then these are just current limited and taking in the input. I think these are AND chips. Yep. This right here just detects the shortfall. So whenever the voltage is lower than its set point, it will show us by how much. I think this is in volts. So you can maybe see toward the bottom there's like a little bumpy section there. I think that's that. So yeah, this thing starts up and spinning. You'll notice it's only going around 700 rad per second. That's because we actually step it up on the transformers, which is how it kind of makes this feasible. Because if you had to rotate this at full power or full rotational speed, you'd have trouble, because I don't have a way to draw a graph really, but I could take like some stone. The way these motors work, they have like a very sharp warm-up, and then once you get up into the higher rad per seconds, it starts to level off like this. So 700 rad per second is pretty easy to sustain if this is like 700, but if you want to get it up to those higher voltages, this is like 900 rad per second, and as you try to increase the speed, the voltage required, which is this x-axis here, goes up a whole lot. Never used blocks in Minecraft to make a graph before. That's a new one. Anyway, similar design to the other side, although I didn't make this one automatic, so the flywheels just kind of turn on when you turn them on. And so then over here, these are the output side. These limited to 4 amps, apparently, on both sides. Inductors, 19 coils. And then this is a step up. So this is, you'll see the ratio is 1.23. So it's stepping it up only a little bit. And this is due to the new Lusty Lavender releases, although I think some other servers might have it. But you can now put 16 cables in a DC-DC converter. So that's pretty cool. And then from there, this should be giving us a very consistent voltage of 3.4 kilovolts. And here's a little thing here. And you can also see here, it's very, very tight. It does, if you zoom in a little bit, it'll look like a ramp. This is honestly more useful. Now you can see the noise. Not much. I mean, this is a range of 50 volts, and you can see it's only varying by about a volt or two, which is pretty good. If I zone it in a little closer... Yep. Oh, wait. Yeah, now it starts to look more like the sawtooth that it is. So it could use a little bit of capacitance, but this is a very, very, very low low voltage differential. This is like, we're talking a few volts. So it's so small that this isn't actually properly represented. It's 3.405, and then 3.3. It's just rounding. That's a good one. Might be worth a bike report. Hey, Bobby. Cool. I'm doing a live stream. Dummy load. What's that? YouTube. Yeah. Yeah, they're redoing the Creator Studio. Kind of a pain to navigate, actually. And I don't play music, so I don't get copyright strikes. Oops, I just touched my mouse. Yeah. Yeah, if you do live streams, you usually don't have to worry about it nearly as much, but I've encountered trouble with that one before. This is another test load. My speaker's been playing out this whole time? That's hilarious. Subliminal echo, I'm sure someone's heard it. This over here, this is an AND gate. I think this is the actual enable thing. And now we're pulling, I think this is 13 kilowatts per side. So add those together. You'll notice the LPF has shown us that we are now 100% duty cycle. And that we are probably short a few hundred volts. Good. If I turn this off, should recover. This is like off the chart down, but it should be coming up. Yep. 33, 34, 35. I guess if you have a really big load, this makes a lot of sense. Okay. I'm going to lower the frequency of this because it actually, believe it or not, affects frame rate in the game. Okay, speaking of frame rate, how are we doing? 50, 59, 61. Whenever I look at the frame rate, it probably goes up. Oh, I see you over there, 41, 38. Jeez. Can't win with these computers. Okay, I've covered that. Test load. I'm not going to really cover this because I didn't really build it. I don't know exactly how it works. It uses SigBus, that's why there's all these funny looking cables going in here. Wayla is really hard to read. Can I get some sky in there? Yeah, the first one says 57.2 millivolts, in case you're curious. Basically, you can have colored cables go directly into a signal bus cable. Oh, I should cover signal cable basics. I'll do that soon. I'll just put the cables there to remind me. But first I'll cover this real quick. So this is a gas turbine I made. The first one actually. I originally was running the server off just basically these solar panels, the grid system. These solar panels didn't provide enough power during the nights. So I made this thing to power it during the day and the night, just to kind of cover for it. I didn't feel like setting up a battery system like is on the roof of that building over there, but I can show you that later. This system here, I forget what this does, but basically it turns this on if the speed is below 0.7. So once it's up to speed, it actually turns off incoming power. This is actually a really cool 3-state inductor system that basically prevents me from having to manually set the inductors over there. In a pull request in the future, I'd love to add variable power inductors so you can change the inductance real time. but this is the next best solution. So when you're starting the motor low rad per second, it'll pull more current, so this will allow it to lower the amount of current that you're pulling through. This one right here has only 3, so it has a little bit more current, and then this one here has nothing, so it's just basically a wire, and that allows full current into this motor, because when you start the motor at low speeds, it will pull lots of current. Once the motor is up to high speeds, it'll pull lower current, because I think it pulls the same number of watts or something to that effect. This one here has an automatic system here for handling the flywheel. It does have a locking mechanism. It's on the wall over here, because everything's just using, here's a flywheel lock, enabling fuel, and the starter. This right here is just a general, like, getting a speed readout. This right here is the entire control system. Basically, if it's above the voltage it needs to be, it turns off. If it's below, it turns on. And this basically is enable or disable. You could also use an AND gate here, but I didn't. Oh wait, no, you can't use an AND gate because this is analog. Yeah, it is. So this will actually vary a little bit. It kind of helps if your voltage is stable, kind of like a rudimentary PID, especially with this low-pass filter. And then this right here is an emergency stop. Basically, if it's going over speed, it will turn this clutch on, which will stop against this fixed shaft. Again, new feature. That's basically this one. I'll cover this building next, and then I'll do signal cables. Where do I start? This is actually a pretty simple system. So we have solar panels here, which are hooked up into these poles, and poles are connected to, on one side, this load of batteries, and on the other side they go into the light controls for the building, the spawn building. The purpose of this right here is actually to lower the amount of, thank you, always Dave command block. I think that's because we had problems with solar. Okay, I'm gonna go back over here. Yeah. So we're gonna set the time to night, and just gonna move the microphone a little closer. It might help. So yeah, this prevents pulling too much current through the batteries. This will actually detect how much current is going in at any point in time. And so each of these batteries can handle, I think, 250 watts. Yeah, 250 watts. So if you put more through them, they'll explode. And since the explosions are off, it'll pop. It'll become an item on the ground. I can demonstrate this. If I grab one of these and voltage source, voltage source. Oh, okay. Well, actually, that did exactly what I wanted. It popped. Yeah. So then we have, basically, this reads in how much current, and it adjusts this op amp to this. It uses this op amp to tell it how much. Invert that signal, run it through a low-pass filter, and then that tells this how much to be on. So when there's low current going through, it'll put the resistance down as far as possible. When there's high current, it'll start to increase the resistance, and then when it gets to full current that these things can handle, it'll just clock all the way over. If it goes over what it's supposed to handle, this will trip. So yeah, and it's not actually drawing too much power right now. 523 watts for all the lights. If I hit these down here, we will find that it's using Hi, Gabe.
Hello.
You don't have to play back the stream in the same room as I'm trying to record the stream.
Okay.
Oh, now it's using 1.32 kilowatts. Electrical timers, they're useful. You said how long you wanted it to last, and then when you press the signal button, it'll turn on, stay on, and once it hits the end of its time, it'll turn off, and you can reset it by pressing the button. So basically all it does is it turns on all the lights in this room, and it actually changes the brightness of the floor lights. There we go. So you'll notice now the brightness is, it's 184 volts over here. I didn't put any lights in there because there's no people over there. But basically people have joined the server, I put them on the wall. You could be on the wall too. And that's not the sound settings. This is the sound settings. So yeah, 184 volts. That's on all of these, I think, actually. I think one of them might have a higher voltage. Actually, no, I think they're all the same. And when I press the button, you'll notice that it'll change. First off, all of these will turn on. It'll change the voltage, these to 225 volts, which is kind of cool. And I'll show you the way it does that. So these, they have different names. There's Spawn BL. I think all the ones down here are Spawn BL. These are Spawn B. Yeah, I'll just let that be. So I have a couple of different light controllers on the roof here. So these ones here handle Spawn and Spawn B. They basically just keep the lights on. And Spawn B has a light channel control here, so it just turns on and off. So basically all the lights downstairs, it'll be load balanced through these two lamp supplies. And this one here handles Spawn BL. Basically when the signal comes in that I want this turned on, it will change which voltage it's using, because again we have these really nice DC-DC converters. Oh, it just switched over. Would have been a good example. This DC-DC converter will lower the voltage a little bit for this leg and not for this leg. So it's 223 coming in from the batteries and 181 coming in just off of this DC-DC converter. So right now the voltage is down, but if I go downstairs and press the button, it will raise that voltage. Just a cool little thing. Let's see here, go back over here. And now the voltage is 220. And you'll notice that this breaker's closed and this one's open. I haven't had any problems with these two going off at the same time, but if it does happen, I have this electrical breaker, which should trip. Should being a strong word. Hopefully it doesn't actually ever happen. But from what I've seen, it hasn't tripped yet, and I haven't had to hit the switch back on. I'm just going to sit here for a moment and see if it'll switch for us. And you'll see at the top there, on the left it'll be 218, and on the right it should go down to 181 volts. Maybe slightly less now. And the voltage is dropping a little bit. There it goes. So now you'll notice this one's open and this one's closed. And the current went down because reasons, I guess. That's a weird one. I think the current would go up. Anyway, don't know what this is. This demonstrates some features of electrical age. Specifically, these are the wireless transmission dishes. I get lots of questions about these ones. First off, you probably don't want to stand between them because you'll catch on fire. I'm making a liar out of me today. Pull some power.
Firing.
Ow. Ow. And some fire damage. Maybe this will work. Because it'll also light flammable... There we go. So it'll light flammable blocks on fire. This one should also start on fire in the center here. Yep. And that might burn the rest of it down. It should hurt the player, TM. Sometimes in creative it'll like catch on fire for like a moment. Doesn't seem to be doing it. Anyway, this is wirelessly transmitting 50, 200, and 800 volts over to these dishes. And in here we have
firing.
I guess I'm in a bad spot. We can put some iron ore in there. We can put some iron ore in there. Those should work. 47 volts, 200 volts, 800 volts. And we know this one works. This is a fun one over here. So this is as designed. We have a 50 volt outlet 50 and a 200 volt outlet 200. And these are new, well, they're not new, but they didn't actually do anything previously. The code wasn't ever finished. But now we have two power sockets, a 50 volt power socket and a 200 volt power socket. And basically you can write the name, put in a cable, and then connect it up, and it'll run these bulbs. Unfortunately, we also found a bug here where you can just, pump 3.2, stupid Dutch JPEG, 3.2 kilovolts into a lamp supply and pull it out over here.
Firing.
No hidden anything here. If I disconnect, it's shutting down now. Oops. Activated. So yeah, I'm gonna stop these. You get the gist.
Firing.
Nope. That's about it for builds over here. Someone made this. Basically, it's a battery charger, but it'll turn off the charging functionality when you put a dummy load on. So it looks for any kind of load, and if you're using the batteries, it won't try to charge them. And when you have finished, they will this could take a long time. Ooh, that looks roasty. And now it's going to try charging them. Now it uses a battery charge indicator. This is actually just to prevent overamp, because this can provide theoretically infinite current. This has some limits. It has moved enough power for whenever the server is actually working. I've had some problems recently. This solar field's pretty simple. It's just basically some relays and probes. This is to measure current, this is to enable. Over here I have all the currents being added together on this little block, and then they're coming out as the or sorry, the wattage, and then all that wattage is being measured in this little shack. So solar wattage right here, output, we're getting around 24 kW. Power factor is 1 on this server, in case anyone's using power factor. Well, it's not technically power factor, we should call it cable factor. It's a weird term. Not some. It's because electrical age doesn't exactly transfer to real life very well, and people don't like the scale, so you can scale it up. I usually run it at 1 though, because that's what a lot of people work with. Yep, and this basically is a small substation that prevents. Basically, it isolates these transformers, because the more transformers you have in a line, the more capacitance it creates. So if you split the lines up with transformers, oops, sorry about that. If you split the lines up with transformers, it will prevent that from happening. Also, it's going directly into this here, and just having some isolation is good. Because if this tower ever goes down from the voltage it's at right now, get a voltmeter. So if this ever goes down to like 10 volts, you can't just connect up these things, and like you can connect these at low voltages when there's no power on the line, but once you have power on the line, it's not a good thing to do, because you can cause these to explode by the inrush current, because they have the same current limit. I think it's 4 amps on the low side, which isn't a whole lot. On the high side, it's even less. I think it's like 1 amp at most. So you want to see milliamps, which we can see it's probably around, I'd say 27% utilization on that transformer. Here we have some more. This basically comes in from that grid and dumps it down here. You'll notice there's a lot of coloring here. I intended to build a 2-grid system, so like we have a green grid and a red grid. The green grid would be, you know, one of them. It's physically isolated by wires on the ground. There's no poles that connect anywhere. And then the red grid would be the exact same thing, but red. The red grid isn't actually connected to any power sources, though. There's no generators or anything. I could put that one over there on it. So basically, the only thing on this one is the solar, and it's backfed by these 2 generators now through this panel here. So basically, the wiring for this is we have the power come in. This right here is actually a charging circuit. We have a T2 charging system from the solar panels over there. This is actually at a lower voltage. So the solar panels actually directly pump into this panel here, which creates a tier 1 pole system that can charge tier 2 and is only designed for charging tier 2 grid transformers, so that once the grid transformer is charged through this circuit, you can connect it up to the poles. So if the poles ever explode, you can recharge this substation through this here. Technically, one could disconnect this pole from there and connect it over there. It wouldn't really cause any difference. So yeah, that's that. This right here is designed to equalize the voltage between the 2 grid systems. Currently, this grid system is at 0 volts, so this would trip out a lot, but basically it would raise the voltage on this side until they're the same and then lock. You'll notice I'm not using the output power on any of those because they're not running. And then this basically is output for anyone to use. Like there's a little fence here just to give you an idea of it, and a little energy meters, and people can connect up their own poles here. I've used most of the poles for this generator system. The idea is basically that people can put whatever they want on that side and it won't blow these cables or the substation itself, because these are all calibrated to 4 amps. The maximum for these cables is 4.2 something, but these inductors will trip first. So it'll do that ramping mechanism I was talking about. I should try and demonstrate the ramping mechanism. I'll do it over here. So I'm going to put one of these down. The ultimate load, by the way, is one of these, Grab one of these, 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 one of these. So let's see here. I'm going to replicate this. This goes here. Got one of these here. And chip with an output to there. I need one of these. Wait, current. Okay, and I need an inductor. Shift click those in there, and signal switch. I will get to signals soon. And one of these. Do I actually want to use this? Yeah, I'll use this. Okay. So we have a voltage drop. Oh, I forgot to put in a current reader. This current readout will look pretty much the same on both sides. $5 amps good enough? I think 5 amps is good enough. I want a chart. What's the range? 5 amps. Okay. Need another electrical. Oh, I already have one. Okay, and connect up our really big load. It's making a liar out of me because there's no capacitance here. I need a pull. That might explode. Nope, didn't explode. Okay, cool. Now it should work. Yeah, it's making a liar out of me. That's wait. That is closing correctly. I guess that was too much for it. Still only trying 4 milliamps. This is a capacitance problem, basically. If I put this here, I think I remember why I put that command block down. Okay. Alright. Need to connect this. Oops. And this here, I'm going to connect with just a basic switch. And I'm going to grab a DC-DC converter. Oops. Okay, grab 2 wires. Isolated mode, pop a killing in there, and now turn it on. It is not having the desired effect. How about we just connect it to the normal grid, because then this will work. Something doesn't seem right here. Oh, you know what? There's way too much inductance. Let me re-add that stop shaft. Okay. Yeah, this actually, there's too much inductance here, so it's limiting the amount of current. 239 milliamps. this needs to be in the highest time setting so you can actually see it, 0.05. Not enough inductance to actually see what's happening. I guess this isn't a very good example. It might be easier to show between two power poles, which have slightly different voltages. Let's see here. This here. This here. Need this here. This here. Don't need one of these. Put one of these just for us. That over there. Need one of these. This is just going to be this circuit here. Current 1.01. Validate. Put some inductors in here and on. Ooh, there's the ramp I'm looking for. Let me raise the voltage a little. Just the range. Right, you have to click validate. The closer these voltages are together, the less it'll do that. Yep, there we go. Now you can see it's a ramp. If you don't have enough inductance, you won't see this. Also, you have to have a small enough amount of change. But you can see it's a pretty decent ramp right there. That wobble you see on the ramp itself is actually caused by the variable voltage in this system here. If I grab this one wire I had over here, put this down here, put this to 3500, 3300. Actually, this is around 3.8, I think, right now. Oh, no, it's not. 33335. Okay. So the wobble you see here will correspond closely with the wobble you see over there. Not too bad. This is actually a pretty horrible example, come to find out. There we go. Set this to 4 amps and you'll see what it can really do for current. Pretty big power sink now. If I grab a meter, how much is this sinking? 3.48 watts. Let me thing here. I'll put this over here. Connect up a wire. Actually, I want to put these down first. Just one. Then one of these. And I'm going to grab a clutch. Just this. The clutch pin will lock the clutch once it's engaged, and I don't think I want that. That's where the clutch pin goes. And this is what a clutch pin looks like. And I'm going to grab a button. I'm going to put it here. And I'll connect this over to here. And you'll be able to see the current is a bit... There you go. 17 amps. Starting current on these things can be pretty big, so if I get the voltage meter out when I cause this... 60 kilowatts. Not bad. Yeah, it draws a lot of power. So if you really need a really big sink, this thing can sink almost all the power one of these poles can handle. In fact, I'm wondering if it blew up any. Nope. Yeah, these things can sink almost the entire T1 grid. Just by resisting. So yeah, you'll notice if there's less current, more amperage is applied, you'll hear the volume getting louder. Oh, you can see it here. There you go. So yeah, if you have more, that's why when I had this thing full with 19, it didn't really look like it was doing anything, because it honestly wasn't. It's 5 milliamps. But when you bring it down to like 4, it'll apply some current. So that's why this starter over here on this gas generator makes sense, because on this side it's using really, 5 is relatively large, then you got 3, and then you got nothing. So that definitely, high power pole, that definitely holds back the power quite a bit on, or the amps on the higher, or the lower voltages. That's the one. That's all I got here. Let's hop over to the generator server. Oops, I should move the microphone a little away from the keyboard. I'm sure you guys love hearing the blues. Geez, I can type. Dev. The address for this one, in case you're curious, is that. Enough time for you to pause. Let's see if the server crashes when I join. Very well could. And the TPS is... Wow, we've increased the TPS horribility. That's what happens when you have what I'm about to show you guys. So this stuff over here, actually, this is an older version of the server by a little bit. It has some of the basic stuff that we built initially. But then we were having a lot of lag problems, so I actually copied this one, and, basically said, okay, this is the generator server, and the other one I won't make too many generators on, because right now the generator code is kind of bad, and you'll also see why in a moment. Can we just not have range in it. So we got a, I didn't make any of this actually on this server. So you got a steam turbines, steam coming in, running all these generators. Risky design. Looks like it gets the job done. Oh, and it powers this computer, which does nothing. Over here we have... There, for all intents and purposes, it's not raining. My FPS will drop when I get over here. Yep. This, by the way, is very bad. This kind of thing right here. This is an op command. Might actually crash the server. Yep. I guess I'm not seeing the output of that one. We'll wait for that to recover. Yeah. Much better. Are there other things I should cover? I love the mood swinging animation. I'm reading comments on YouTube right now. Feel free to say what you're looking for. Why would you do that? It should come back in a minute. Either that or it's totally crashed. Why would you do that? The lattice work of cables is one comment. Someone, oh wow, I just saw in the stream the lightning hitting the ground in the background. The lattice work of cables allows you to transform more current, more current, but it does a kind of bad thing, and I'll make an example of this. Kind of difficult to explain because the oh, this is really funny because I turned off the rain and didn't turn off the splash animation. I'll go over to a single player world. Creative, superflat. Oh, that's not the name. Okay. Alright. Open computer's manual. Let's go to electrical age. And we'll grab some cables and, I don't know, one of these and maybe a resistor of some kind. Did I scroll past the, yeah, I did. Yeah. And one of these. I need some dust as well. Alright. So put this down. Put a resistor down. Put some of that in there. And I'll make an example. An electrical source doing 320. Okay, 1.47 amps. That shouldn't explode. That might explode this. Let me lower the voltage a little. Okay, 1.83 kilowatts. That won't actually blow it up. So this right here will be, let me not full screen, because I'm going to pull up a text editor. So this right here, Eln dump or matrix, sorry. Used to be called dump subsystems. 2 subsystems. I'm going to guess that this is getting split into 2 subsystems right there. Average subsystem size is 2. So if you go to your multi-MC folder, or wherever your Minecraft is, really. This is Arch Linux, so sorry about that. Jesus. Let me turn down sound for... There we go. Let's see here, multi-MC, instances, Lusty Lavender, we're going to go to .minecraft, it's kind of hidden. And then there should be a file called eln dump systems, subsystems, and you'll notice there's, looks like 1 subsystem actually. Yeah, it's just 1 subsystem. Pretty simple. This is how the internal state of the mod kind of stores it. And if you have a very small world with, you know, only 1 electrical age thing in it, you'll actually get this as a result. So you'll notice we have, it would really be smart to run this through my program actually. I'm going to do that because this is kind of hard to understand what's happening without a pictograph kind of. So let's see, github.com /sharededundr /eln matrix viz. I think it has a Z on it. There we go, with dashes in between. I'm going to just download this because it's something people know how to do. Okay, grab a file manager. I'm going to grab that file actually. Sorry, this is taking a moment. Local, share, multi-MC, instances, MNA, Minecraft. Okay, I'm going to bookmark this. Okay, so we're going to go here. I'm going to copy this into... There we go. So if you copy this file here, I'm sorry this doesn't really work on other systems. You could probably do this on like Windows subsystem for Linux, and this might work with a Mac if you have all the correct software. So no such file or directory .0. Weird. Never got that bug before. Welcome to writing Python code. We've devolved this session of, can I get line numbers, please? That's the next best thing, but I'd like line numbers. Thank you. 172, I just want to see why this is giving me trouble. Oh, Python. Yeah, W+. That's correct. Such file or directory. Well, you're a pain. That's why. Sorry, that's more work than it should have been. Oh, actually, that just worked fine. Okay, so if we go into the PNG folder, we'll see what this actually looks like. So we have a voltage source. This is technically a voltage source with a voltage of 0. It's actually the exact same thing internally as this, except this actually has a voltage that's configurable, and this one is always 0 volts, and it's not configurable, but it's the same kind of idea. You can also technically put that in there. And the rendering for that is broken, I'm aware. But basically, this right here is the same... Oops. Let me just kind of put this in perspective right here. Yeah, there we go. So... I can rotate this. Is that correct? Yeah, that's correct. Okay, so now you'll see we have, on this side we have the voltage source. This is an electrical connection. It's kind of an internal thing to this. Otherwise, it's a resistor. So this is a resistor. And then we have line, which this entire thing gets shortened into line. So no matter how many wires you have in this, like, because each of these wires has resistance. If you measure the voltage across this, it will differ. Let's grab a multimeter real quick. Should get, it's rounding it, but the voltage will be different. If you have a bunch of resistors, this is easier to see. Like if you put like 3 resistors in a line with wires between them, you can watch the voltage drop. Here, I'll do that real quick. Put one here, put one here, put this here. A wire, this thing, 200 volts. Is that what this is right now? Something like that. Copy in some dust. And the wire in the middle here should be exactly 100 volts. 200. 3.63 millivolts. Yep, so that's basically what's happening, and when you have more wires, it will split the voltage 3 ways, and et cetera, et cetera, et cetera. Let me remove this, because otherwise we will see it, and we don't want to see that when we do Eln matrix with this. Close without saving. So we're going to run generate matrix again. 2 subsystems, average subsystem size 4. So we've increased the size by something. I'm going to copy this file into here again, replace. I'm not going to look at it, but it's different. Okay, going to go in here, grab our PNG. And now we have something a little different. We have, this is actually kind of weird. We have a line, so everything on this side is line. We have an electrical connection and a line, and then we have a line. Oh, this is electrical connection because it's only one block. So if I make this bigger, like this, and regenerate everything, it will change slightly. Replace. Generate that. Open the image. Yeah, now it's both line and line. Because when it's just directly like, you know, like this, this right here, because it's directly adjacent, will be electrical connection, and this will be line because it's 2 resistors, not 1. Okay, so that's that. And I think right now MNA doesn't really do anything about this. It'll technically be a subsystem. See, there's 3 subsystems now. But if I copy this in, replace, I know this must be really boring at this point. So we have that one, but also if we look at the subsystems, we'll see there's that one subsystem, but there's 2 empty lines, which are subsystems that don't actually have anything meaningful in them. Yeah. Oh, and that explains electrical connection, because this has an internal resistor which is connected directly to this. These have internal resistors, so they don't immediately explode. Like if I do this, they don't explode, because this has a resistor in it. That's why it has 8 kiloamps. If you didn't have a resistor, this would actually crash the game. Fun fact. So yeah, when you have a lattice, though, this gets really complicated. That's actually why we brought out the whole MNA in the first place. I'm just going to dump the subsystem again. Now you'll see it's 25. You can look in here. Oh, wait, I need to copy this. Copy this from here to here. Replace. So now you see it's a really big thing. Do that, make a PNG, and oops, didn't actually make a PNG, I just opened the old one. There we go. Now you'll see it looks a little bit more complicated. This is very hard for the solver to solve, because it's basically just a really large grid of resistors, and each one of these resistors will have different resistances, and it actually makes a really big mess in the MNA, and this will cause tons of lag. So I think I covered that question pretty well. I'm sure someone has another question like, why are you doing all of this? Nice. Yes, you noticed my mistake. Thanks. Yeah, so that's this. So yeah, I'm going to go back to the gen server if I can. We're not going to run eln dump matrix again, or the matrix command again, because that would be bad. But anyway, that's why this entire thing right here is actually super bad for performance, including this. But yeah, you can technically put more current through these wires because of that, because these will cause cooling of the wires. So say you have a wire going along the ground, and this wire gets, wow, there's the lag. Say this wire gets really hot. You can do this thing where you have the cable on all sides like this, and this, we call it a Hexorian antenna, long story. But basically, this will sink heat from this cable getting hot, because this is technically 5 cables in a box, and it just has more temperature resistance. I'm just going to break those 2. There. That won't be a problem, because they're not connected at many, many points. This is going to be laggy. 3 FPS. Woo! So yeah, it looks like there's a lot of generators down here. Originally we thought putting down these clutches would help, because it technically splits the networks, because each network has linear time complexity. That didn't actually end up helping. Tons and tons of flywheels, and then if we go outside here, we'll actually see loads and loads and loads of transformers and generators and stuff on all these floors. This top floor doesn't have anything. I see something more in the distance there, but I think those are railcraft boilers, because he wants to, the person who was building this wants to build, oh, there's nothing on this floor either, wants to build an entirely, you know, like, I think this is like a 3 megawatt power plant. Yeah, this floor has something on it. So these are all going to be, holy cow, 3 FPS. Yeah, this probably took a long time. Oh, I never covered signal bus cables. I'll have to do that. We'll do that back on the LL server instead of the Gen server. But yeah, basically all of this stuff is here. He also has current limiting stuff. Pretty standard protocol, to be honest. This I'm going to assume is measuring whether these are open or not. What on earth is happening here? Oh, I think my game crashed. Nope. Okay. I don't actually know why, but he's connected all these together through the signal bus in large pairs. Perhaps to turn them off. I would suggest using AND gates. That's all I have to say about that. Oh, there's another building? That's why the TPS is so bad. I'm not even going to go in there. Right, it's this way to the large stack of... Yep, those are railcraft boilers. Is this thing full of railcraft boilers or something else? I don't even know. I'm willing to bet this is another building that's going to be full of generators because it's got the same... I gave him world edit permission. It's going to be the same kind of build construct. Holy cow, this thing's huge. Oh, there's another one over there? Wow. Alright, that's a building. Apparently there's another one over here. Oh my goodness. There's another one. Oh man. This isn't going to perform well. Well, hey, if I have to reset the server, I reset the server. If not, then you can deal with it. Lots and lots of stuff there. Alright, I'm going to go back to the, whoops. I'm going to go back to the regular dev server, the one that's actually playable. Whee! So much better. Okay, we're going to cover cables or else. The signal cables. I'm going to grab some of these, and there's also, I don't know if people know much about the signal cables, or actually a lot of the, I'm going to grab some other things too. I'm going to grab some of these. I'll grab some cables. Just regular cables, please. Nope. Regular cable, here we go. Okay. And we'll go over here, where there's less noise. Alright, I'm going to grab a couple of brushes. There's a lot of brushes here. You can actually see, I think there's like 16. I'm going to grab that, oops, and that. Just for explanation purposes, you can, any of the colors aren't significant. I'm just grabbing them because they're visually significant. So black is black. This doesn't actually change anything about this cable. You can color them red, you can color them green, color them, you know, blue, you know, and you can color this one red here, and color this one black, one here. Ta-da! Oh, it's already black. Duh. Cool thing that not a lot of people know. Press C, right click. Color care allows you to connect wires of different colors. So this wire here will now not care about the color of the wires that are attached to it, and it'll connect the wires. So if you want to do that in some place, you know, you just need to connect one color to another, or something happened, you can easily do that. And it doesn't matter what the color of the cable is, you can just put a black one here, press C, right click, does the same deal. So that's super helpful. I'm going to put this out of the way a little bit. This only needs to be, oops. Cables are a little jank sometimes. There, that kind of gets the point across. Color pair, maybe I'll put a sign down so people understand. Grab a sign. Okay. So let's see. I've covered this. SigBus cables should not be colored. That's kind of buggy right now. It does some weird things, but basically SigBus allows you to put 16 signals in a single cable. So you can have, like, you know, a cable here, a bunch of stuff here. So by default, the things coming off the SigBus cable and the SigBus cable itself are black. You can change the color of things going into the cable. You can have them arbitrarily exit it or enter anywhere you want. You know, I can put a blue one here, blue one here. Okay, so I'm gonna grab, I think that's good for those. I'm just gonna grab a indicator of some kind, or a button rather. Button. Should be, oh, they're on the wall and they're wireless. I want regular button. Just to be able to turn these on. So do I have 3 colors somewhere? I have 3 colors here. Here. Oops, I'm an idiot. And there we go, VU meter. Oops. So if I turn green on here, it'll turn green everywhere else. If I turn on red, it'll turn red on everywhere else. If I turn blue on, it'll turn blue on everywhere else. There's only one spot. And if I turn black on, it'll turn black on everywhere else. And if I put a button directly on the cable, it will... this will turn black on as well. Okay. Black is 25. There we go. That should... Yep. It's because it's splitting between these two. It's acting like a... kind of like a split. Because this is holding it to 0, and then this was holding it to... See how it's 25 volts there? It's kind of like... These cables have a lot of resistance. Really weird. Anyway. So that's how you do that. So you can have up to 16 colors in a cable. You can see at the top here... I'm moving my hand to my screen, and you can't see it. Yeah, anyway, top of the screen you'll see SigBus cable. That's Wayla, by the way. It has all the colors of the cable, and you can... I think one of them is brown, and we have brown here, but there's no brown text color. We tried to match them as close as we could. But anyway, that's how that works. And then I was going to talk about these. So these, and a couple other things... they can be colored. I like the black on this one the most. Make you a little green, blue, red. You can change it back to white, I think. Yep, white is the normal color. I don't know what the gray looks like, actually. I'd have to place another one of these to know what's the actual proper color. I can't actually tell. Okay, it starts white. For anyone who's curious. Oh, I should cover clutches. Clutches.
Firing.
Oh, I'm getting shot at. I'm gonna go over here. Clutches are fun. So we can get a small motor, electrical source. I'm just gonna get a regular basic old clutch. Joint hub, joint, and I'm gonna place these down in such a way that I can control the output. So I'm gonna put this here, this here, this here. I'm just doing this so that I can put a clutch like here-ish, and I'll be able to stop it if I need. I need the stoppage clutch. Clutch of stopping. Okay, I need a button. Button. Here's a button. So this will allow me to stop it. This will allow me to start it. This will allow me to stop it. I'm going to use clutch pins and iron clutch plates in all of these because they're pretty much the best there is. Yeah, I know, I'm already picking favorites, and we just installed the feature. Get this up to speed. 7.3 amps. Okay, and when I enable this, it should get this thing up to speed, and I can stop it here with this. Might want to put a flywheel on this motor. Nah, I'm not going to worry about it. So you'll see that. Oh, new feature. When you do this, it just explodes it. Because it's rotating too fast. Might be heating up this motor a bit. Heating it up a little. So yeah, you can stop it and then put the thing on that you want to put on. Ta-da! Oop, apparently we got this one rotating. Okay. So let's put this here, and we'll talk about the different kinds of clutches. So I'm going to enable this. I'm going to put this here. So now this will be the effective clutch. This won't actually be, I mean, I could put another one here just to add to the effect of, the stopping effect of this one. You can actually just kind of stack these. The wire will even connect for you. It's kind of fun. Put this here, right click on this, put in a clutch plate and a pin. Awesome. These have pins. I'm not going to use pins for the rest of this because you basically understand what they do. They just lock the state. Once it's locked like this, this can't move. Technically I don't need these, but this could rotate a little. I can remove these and see if it rotates once I start playing with this shaft. So if I put the clutch plate there like that, and I start this one to lock it. Oops. So this one should lock. Yep, see it says slipping now. That means that it's locked, effectively. This shaft shouldn't change from side to side. It can if it's under a lot of load, but it usually doesn't. And then you'll see on this side that we have one shaft stopped and one is not. And since this one is locked, we'll see the braking power of this clutch. So you'll see here this kind of has a problem with not being very great, but it's okay. And this side you'll notice is, oop, the motor finally exploded. Let's put another motor down. So you'll see this side still is rotating even though it's got clutches, and if I remove some of those, you'll actually see it increases the speed a little. Oop, we blew up our shaft motor again. Can I put down 2 of these? You'll see it was up too fast already. Just gonna break that and place this and this. It's already up to speed so much that I can't even place one. You know what? I could just set this to 0 and then do it. Okay. And I could even do that. Oops. Did not mean to do that. I think I pressed full screen. Okay, so that should bring this up to speed. Nice. So that's how that one works. I'll touch that and take that clutch plate out. These don't stack once you've actually done that. Let's see here. So we have a couple different ones. I'm trying to find visually where they are. I'm blind. Here we go. We have gold clutch plates. We already had the iron ones that I'm using. Gold, copper, lead, coal. I use the coal one last. Kind of has a fun feature. So gold, I can't remember what the curves are on these, but they have different curves. Like some of them have better stopping power, but they wear down faster. So this one looks like it had better stopping power, but it might... You can see the wear going up. That's out of 1, I think. Nice. just, you know, could get a motor that doesn't explode constantly. Yeah, I don't know how I want to go about this. 46 amps. What is the current on that? Yeah, 149 kilowatts, nothing to sneeze at. But yeah, so it's wearing down a little bit. It's not wearing fast enough for me, but it's wearing down a bit. Copper. Copper, I think, is a little worse than gold, but has a lot of stopping power. Apparently enough to cause these to slip. Maybe not slip. Oop, there goes the motor again. Did this wear faster? I don't know that it did. Lead should be really horrible if I recall. I don't know. The coal clutch plates are kind of bad. Jesus. Okay. This is what the coal do. It has a little bit of a different behavior. It really doesn't have any stopping power, actually. I don't have explosions on, but if I had explosions on, you would notice they would be exploding right now. The exact purpose of the coal ones is to just explode. That's all they do. They never actually stop anything. They might, but not for long. So that's clutches in a nutshell. What else can I talk about? Oop, there's only 2 pages here. So you have cables. SigBus is a recent addition. Lamp sockets. People might not know how these two work. The projector one, I think... Hold on. That should make a nice big cube. Okay, let's get this nice dark room here. And I'll place that on the ceiling. I will put it in powered by cable mode. 200 volt cable, an LED, and a power supply right here. 200 volts. Pretty standard, you know, it just lights up the floor. This one, I think, is the one with the directional control, though, so now I can project over there. If I press C, I can rotate which direction the light turns in. I can put it at like 45 degrees so that it lights on a wall somewhere. You can also make that negative, or I can just rotate it, but if you put it in negative, it puts it on the other wall again. So that's that. Lamp A. For a time, the crafting differences between these was actually broken. So I don't think I might have actually seen how lamp A works, but yep, lamp A just looks like that, and lamp socket B is a projector. So the projector one is the interesting one, I guess. The lamp A is just a lamp B without the rotation. Some more lights, more lights, more lights, more lights. These ones will swing in the wind. It's kind of cool, especially the long one. You would have noticed it on the other server. It did it before I crashed it. These exit lamps. I've seen other versions of these exit lamps, so I wonder if that's been updated in the mainstream releases, because this is the fork release. Like I said, these power sockets now work. Apparently, all the way up to 3.2 kilovolts or higher. Well, that voltage tier. Let's put it that way. Data loggers. I think you can color these ones as well. Let's see if I can make it black. I can make it black. That actually looks kind of cool like that. This one, can I make it black? I can make it black. Yeah, so these work too. What else can I do? These ones we know we can color relays, signal trimmer, signal switches, wireless buttons, diodes. The signal diodes are really broken right now. They don't actually do what they're supposed to. Let me demonstrate. Let's say that I have signal wire, and I think I'll just use this, and I'll just look at the voltage on the wire. So right now it's 0 on all those. Press that there, press that there. So one of these, you know, it's 50 on this side and 50 on this side. One of these should be the low voltage, and one of them shouldn't be. So the forward voltage across these is not doing what it's supposed to, and it's kind of hilarious. I'm going to go with one of these being bugged. Anyway, it's because these cables have so much resistance that the diodes don't do what they're supposed to. Because, fun fact, if you have, let's say you have, actually a switch will do the trick here. Let's say you have a switch, and you have power on one side, it's 4 kilovolts, just to make it clear. You'll notice there's 4 microvolts on the other side of the switch. And then if I put a wire on the other side, connect it so it goes from 4 microvolts to 4 kilovolts. Why is there 4 microvolts here? And I don't know how effective it is to pull that power. I don't think, yeah, 3.99 microvolts. It does exist. Does this pull current? No. Okay. But basically this microvolts here is because this is actually just a resistor with a whole lot of resistance in the open state and exactly the cable resistance of the cable tier in the closed state. So this is basically the resistance of this cable. This is high Z. It's like you could do the math actually because you can see the 2 voltages and you can calculate the resistance. I think it's a mega ohm. Might be like 10 mega ohms, maybe a little more. But that's how that's actually done. So the resistors are basically a fancy version of this. I can actually emulate almost what they might actually be exactly the way the resistors work, but basically the idea behind the resistors is that you have something like this. This and this are the same thing. It's just this one uses a signal, this one uses a switch. Like it uses player input. This one you can't really, I mean, it has player input, but not strictly in the sense you would normally care about it. And basically all it does is it checks the voltage on either side, and if the voltage on one side is bigger than the other and it's not supposed to be, it will open the circuit, and that's basically what it does. And this actually takes time. If I do this in the real world, it'll take a tick. I think the simulator also takes a tick. So that's why you'll notice your diodes, when you initially start them, they don't actually work. And other problems with diodes. And it's just because there's limitations in how you can actually do that, because the whole thing about this is that the matrix calculation has to happen matrix calculation, it only really, you want it only to happen once. If you have to do it multiple times, you're spending a lot of CPU time. So it's best not to have to do that, but at the same time, you need to know the voltages on either side. You could use the ones from the previous round, but that kind of defeats the purpose because you need to wait for those voltages to actually change, so something explodes by the time your voltage happens, and that's in time of ticks, not like pre-ticks. Like sometimes it'll do certain things like 1,000 times in a tick just to kind of make sure that it evens out. Yeah, you can't really do that with diodes without things exploding. So diodes don't exactly work the way you intend them. On generators, they tend to work okay. They will leak power for a tick. Alright, I think I'm done in there. Okay, so we have those diodes. Power capacitor, it's just a capacitor. Power inductor, it's just an inductor. Resistor, rheostat. Rheostat is literally just an adjustable resistor. It takes signal input, I do believe. That's, ooh, So it should take this on either side. What's this side do? I guess you can only do it on this side, and it doesn't even render to show you which side, which thing it is. But if you grab that signal trimmers are useful. You can just specify, you know, percentage, and you'll see it'll change on that slider there. So it'll change the resistance. So at 100%, it's 10 milliohms, sorry. And then at 0, it's 0 ohms. 0 in air quotes. Okay. Thermistor, I don't know if that actually works. But basically the idea is that the warmer it is, the more resistance it'll have. But I don't think that... Maybe if you pass current through it, it'll actually change the resistance. I'm not sure why that would be useful. But let's say that we have some current. Yeah, the resistance changed. It might actually still have a temperature. Yeah, it's 20.6. As that temperature goes down, the resistance will go up. You can do that weird thing with cable resistance like this as well. Or the cable temperature. Let me add a resistor to make this a little bit more clear. Grab some coal dust. And the ground pin. Okay. And as this cable heats up, the resistance will go down, theoretically. Might need to increase the voltage. I need to cool this thing down. There we go. There. Okay. And this isn't drawing enough current. Cable actually isn't heating up. Let me put one of these on. Yep, that increased the temperature of the cable a little bit. It went right back down because of this thing. I think like 5 cables in one. If I lower the current, this generator will pull more amps. Jeez, this is difficult. There. That should heat up this cable. Oh. That cable is heating up way less than I expected to. I'm going to put one of these down. Yeah, I don't know. Supposedly the resistance changes when you get it warmer. You can see it a little different there. That's all I got. Clear all that stuff out. Go through a little more. Switches. Electrical breaker. They are very similar in operation to... Where is it? This. So this is very similar to if you have one of these, one of these, one of these. By the way, this is also a high resistance thing. It's going to be exactly like this does. If I put a wire in it. Switches, there. Switches on. That should, oh wait, no, off. Yep, microvolts. So this and, oops, and this circuit here, could use color there, doesn't really matter. Oops. And put one inside. That and this. Actually not this. It's this. Fun fact, you can put a wire in here. Should be able to put a wire in here. You actually need this, I guess. Oops. Fun fact, you can measure the temperature of your cables. And this can also measure, like, if you've ever used, like, the heat furnace, this is where it's more useful. You can measure the heat of a cable, thermal cable. But this right here, if I grab a signal cable, this right here, this would be in voltage mode. I think there's also one in current mode. I should check the code, but basically this is all connected into this. And basically, if any of these is like a bad voltage or bad current or bad, I don't actually know that it checks current. I think it's just voltage and heat. And if the voltage and the heat are bad, it will turn off. And with the electrical breaker, it actually gives you less flexibility because this thing has to be turned on and off directly by hand, not like this. I didn't really set up this circuit very well, but basically you'd check to see if the temperature got up, and if this went over voltage or over current, you'd turn this off. These two ranges are not hard to do. You can do it with two of these and an AND gate and some other logic. Okay. Energy meters. It's basically a small resistor, and it measures the current across it. I think it also can be used. Regular energy meter has password, counter mode, just counts kilojoules. This one counts time as well, apparently. I think that's the only difference. Apparently it doesn't even show it in the GUI. I actually have no idea how this password is saved. SDF, DSF. There. Apparently you can change the password. These operate the same way. Set an energy counter, blah, 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 blah. Electrical fuse holder. This is basically this, except expendable. So you have a fuse holder, which is actually voltage agnostic, and then you have fuses. Here they are. You have fuses of different sizes. Ta-da! That's been in there for a while. Okay, fuse holder. Electrical probes. These probes are incredibly useful. I actually redid the textures. That was one of the first things I did. So you have different kinds of probes here. We have this kind of probe, which can measure voltage, current, and power on electrical cable. This can measure voltage on a cable. The reason this can measure current and this can't, this current and power are highly related. Voltage times current equals power to some degree. And then this is just measuring voltage. It's because in real life, you measure the current through something. You can't just measure the current on a wire running adjacent to something because, like say I wanted to put that probe here. The probe doesn't get the current. The current doesn't go down this wire. It only wants to go the quickest route, which is straight. It doesn't measure here. There's no current. So that's why you can only measure current and wattage on the inline probes, which is why you never see me carrying around the other ones. And then there's these two probes, which are useful with this, and also some of them work with cables. So this one here, I think only, so you can't put the red one in there, but you can put this one in there. And this basically allows you to measure thermal power or the actual temperature, similar to volts and watts. There isn't really an amps equivalent, I don't think. And then this, you can measure this, or you can also measure cable temperature. You just put another cable there, and this will measure temperature. It's going to lose a little bit. I wish that it worked on the inline ones to do TM. Also, it looks kind of funny with the way the texture works. Anyway, that's that. Analog gauge, these are pretty simple. Voltage changes, it'll change. I'm just going to grab a sine oscillator just to... here we go. The white side is always the output. Okay. Really slow sine anyway, but that works like that. This is a VU meter. It shows whether something is on or not. I actually already kind of demonstrated that. This is a nuclear alarm. Makes noise. This is a standard alarm. It also makes noise. All of them are annoying. I'm pressing C, by the way, when I do that. Oops. Yep, pretty annoying noises. VU meter. Yep. This takes a little bit of time to actually go where it's going to, which is kind of annoying. I don't really use these ever. Okay, just remove all this stuff here. Don't need to hear these motors in the background. Just clean all this up. Okay. Clean this up a little. Okay. Okay. Daylight sensor and electrical light sensor. So these basically detect the light in the room and they'll change the stuff. This does exactly what it says in the comment. Provides a signal based on the weather. Shows wind speed. I don't actually know how well this works. Oh yeah, I'm moving. Yep. Electrical fire detector, which I think will literally just output a signal. Yep, it just outputs a signal. So if I catch something on fire, it's going to be very angry. And I'll grab one of these while I'm at it. Need a battery. Battery. Here we go. Oh, looks like we need a charger. I'm just going to use the one on the ceiling. Pop on some batteries while I'm at it. I'm going to grab one of these. We have capacitors too, yeah. And we're going to boost this. Booster. Where is it? Here it is. There. That's going to charge those batteries and those capacitors really fast, apparently, with the capacitors. put more of these in there? No. I'm just going to be another one of these with oops. It only charges things on the top row and then the bottom row. That's kind of lame. Maybe we'll get some batteries going. Oh, this one's done. It's a capacitor, but potato. This one doesn't require power for some reason. Okay, let's light something on fire. Something really basic. Yep, there it goes. And this one makes an annoying noise. Do they both make annoying noises? Oops. Oh, there we go. Fire detection level 11. Okay. Just put that in there, I guess. Yeah, this one doesn't make noise. It just detects if there's fire. Handy, I guess. This will scan objects in a container. Be like, I got this chest with, a bunch of stuff in it. Oh, fire has gone out and the meter went down. I don't know. We're gonna throw some junk in there, and 7.3% full. Yeah, that's it. Okay. These are redstone to voltage converters. Basically, if you want to have a redstone signal coming in or out of something, you just hook up the said signal. You will lose accuracy in your data. The signal cables can provide immense amount of redstone value 1. So this technically has an output that can be measured over here. You'll see how the voltage has been rounded. Let's clean this out actually. Oops, those are handy in there. Those are useful. So is that. Yep. Yep, those exist. Electrical timer, I actually showed you that earlier. Signal processors can do a ton of things. So you'll notice they only connect on the output side automatically. But if you put in an equation, it'll turn on that side. So you can put in B, you can put in C. You'll notice that the inputs are A, B, and C, and they're color-coded. And so you have A is red, so you have the red side, green is B, and blue is C. The more complicated the thing you put into this is, the more redstone you will need to put in it, which is why I always have some redstone. Yeah, tree resin collectors. They collect tree resin, you put them on the side of a tree, and then you roast the tree resin to get rubber for cables. It's kind of a survival thing. Analog watch. This is actually a wall clock. And it requires batteries, and it only shows you Minecraft time. I'm going to put a capacitor in it. Apparently it's high noon. Yep. Okay, we're going to put concrete on the wall, I guess. Okay. Digital watch, the same thing as the analog one, except it's digital. Digital display takes in your analog signal and shows it. This is the side. Usually I place these on the wall. They're a little buggy still. Oops. And, yep, that's that. 7.3072. You can remove a 0. Oops. Oop. Add a 0 is what we wanted. 729. That's more accurate than this is. Nice. And these really shine when you have a sig proc. I call these sig procs. 2/256. We'll put a decimal digit there. Oops. If you have 1/256, it'll put 1 there. 2. If you put 4, it'll light up the next digit. Put in 8, it'll light up the next digit. So that's that. So those are just the decimals. There's actually decimals all along the bottom. And then there's a decimal here, 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 and here. And you can turn on all those decimals with this. So you can just be like, oh, I want to, you know, turn on some decimal points. And there you go. You got some decimal points. Wow, that was by chance. It's kind of up those two and then down. Anyway, yep. So you can do all sorts of cool little displays, clocks, whatever you want to do with this thing. It's very manipulatable. We may remove some of the features that it has because holy cow, you just have 200. You can't even use this thing without a sig proc because it's so complicated. Let's see here. Tutorial signs, they're not actually useful outside of the tutorial world. They do absolutely nothing. But if you have a tutorial sign, you have a world file, you can click this, you can set a name, and it'll pull lines out of a file. And it'll actually just put them in the world. So you could use this for like a server if you wanted. But you have to have the world file accessible to be able to put anything on it, which is kind of lame to be honest. Let's see here. Now we hit the gates and stuff. Not chip, and chip. You can look up what these do on Wikipedia. NAND, OR, NOR, XOR, XNOR. PAL is a little fun one. Basically, it does logic with these. So if I grab... It's almost like a, maybe like a tiny FPGA. I don't know if I'd describe it as that necessarily. Put 3 things on the sides here and then 1 thing on the output. So right now, inputs do nothing. But if I have no red but blue, it'll turn on. But if I have red on, it'll turn off. And green doesn't affect it. If I have that on, it'll be on except for whenever... It's just flipping blue. Yeah, it does things. You can click multiple of these and it does other things. Basically, any combination of gates you could possibly want to make, you can make with the PAL switch, PAL chip. So like if you were going to have like a ton of these to handle 3 inputs, you could just use a PAL chip. Thing is, it's only, from what I understand, it's analog. Let me get a wire on that. Yeah, so not extremely useful for analog stuff, but for digital it's fine. Okay, we're PAL chip. Schmidt trigger. Fun fact, the relays already do this for you. The Schmidt trigger and the relay don't agree at the same voltage though. There's about a 2 or 3 volt difference. D flip-flop, it's just a flip-flop. You can look it up on Wikipedia. Oscillator literally puts out a signal. It's very similar to the sine chip that I was looking at earlier. You specify the voltage in on this. You specify the frequency in as a voltage on this side to some degree, and then the output wave comes out on that side. It's gonna be like a square wave. Flip-flop, you can look that up online. Op amp, basically I don't remember how these work, but basically you put in something here, put in something here, and it'll compare it. PID regulator, these are incredibly useful, but the SigProc does it better. KP, KI, KD, you can look it up on Wikipedia. Sawtooth, sine, amplifier. I think it's literally just a multiplier. You can use it as a summing unit, basically, and this is a VCA. I don't know that I even got these two to work the way I expected. Sample and hold, you literally sample something. So say I have this device here and I want to save the voltage of some random thing. Let's see, I have a signal trimmer and we'll put this down. Actually, handy. Put this here, put this here, put this here, here. Grab this, here, here, here. Okay. So we have this voltage coming in. Sample and hold. I think the sampling will allow it to change dynamically. Well, only does rising edge. Okay, good to know. Low pass, I already showed you what these do. Basically, if you have a high frequency, you can adjust, like you can make it basically is a big summing, like overtime summing unit. It's like the KP no I on a PID. Large rheostat, this is a big resistor at its heart. You can change the resistance with the signal on the front, but it'll always have at least some resistance. Put in coal dust in the slot to change the resistance up to a stack. Nixie tubes, these are fun. I'm going to grab some wires for this one, and we need a SigProc. SigProc, here we go. So these are supposed to be simple. And actually, I didn't cover all the features of this. In addition to being able to slap this on a wall and show a signal, connect the wire on that side. Oops. You connect a switch. Let's connect another one of these just to show how it works. You can actually connect them in a row like that. Oh, you can turn it off. These have the same mechanism. Turn off your light. I think, yep. So that's basically, you know, signal input, so you can have like a, you know, if you have like a better signal. One. almost filled it actually. Let's put another one in there. Two. Nice. And then this on the back here, you can change the decimal points on the side. It's actually only 4-bit or 2 bits of data, so you don't actually need it's easier to control with this, basically, is what I'm trying to say. So that'll put the bottom digit, top digit, both digits, no digits. DC-DC converter. So you can put up to 16 wires on one side and 16 wires on the other. And while everyone uses the optimal cores, there's actually 3 of them. So these ones are really horrible. These ones are less horrible. And wow, 150 and 1. So yeah, this is the most optimal. It'll literally just 1-to-1 whatever you're doing. And if you remove something like that, you can change the voltage coming in and the voltage coming out. So let's grab this. So let's say we're putting in 10 volts. 10 volts here, 20 volts out. If you take out this, it'll be 10 volts on that side. If you take out this, it'll be 5 volts. Take it out again, it'll be 2.5. Take it out again, it'll be 1.25. And you can throw more on that side to make that voltage even smaller. Or you can reverse it. 160 volts over here now. Basically, it's a big multiplier. Okay. What else can we do? Heat furnaces, they create heat. These, you cool one side and you heat the other. And these use those thermal cables. Oop, that's SigBus. You can use these thermal cables. So you can also use those temperature measuring things. Let's see here. Guess I'm just going through everything. Those, we've covered these pretty well. Covered these already. How to connect them, you can come to the server. Different batteries have different things going for them. This one's a fun one. Electrical furnace, you can actually upgrade this thing to Industrial Craft 2 induction furnace speeds with this one. So let's say I have this, regulator slot. I don't know, we'll just heat it all the way up on. And we'll set this here. Uses lots of power. 12 kilowatts. It's up to temp. Apparently it's really hot. And if we put in some ore, it's going to cook. That's pretty fast. This requires an obscene amount of tungsten. It will require slightly less later, maybe. That's how you get a stack of copper. Let me clean up all this stuff on the floor. I'm gonna go outside. It's a little brighter out there. Okay, cover that. Arc furnace makes stuff. Ooh, good voltage. Work in progress on that one. It doesn't even have a finalized texture yet. Egg incubator literally makes chickens out of eggs. That's about all there is to it. Auto miner mines things. Solar panels of different sizes. These ones tilt and tan. These and pan. These ones tilt and pan. Wind turbine, water turbine, really underpowered. These you can use to cool the opposite side of these, the cold side, to keep it cold. Experimental transporter transports you from A to B. Vents turrets, you've already seen these. They use player filters and other filters that are here. So you can make them filter, okay, I want to shoot players or not shoot players. I can want to shoot or not shoot monsters, or shoot or not shoot animals. And there's also the option of not having anything, which will change that as well. Generators, they're extremely jank, but they produce power. They're relatively efficient, but they also are a pain to use. Try to use more power than that and they just shut off. Grid transformers, they're used for grids. There's a bunch of them over here. I covered them earlier in the stream. Poles, covered pretty much all of these. 2-2. Ores. These are... Arc clay and arc metal are basically the same as aluminum and steel. They're ore addicted for it. Energy converters, you can convert to RF, EU, like so, any kind of RF mods. EU, you cannot convert back into electrical age by that way. You need to create steam for the steam turbine or produce fuel. Eln computer probe, you can connect to computer craft or open computers to control electrical age stuff. There's stuff on my GitHub actually that has stuff about this. Close this. Let's see here. This one maybe. Pretty simple. Finds a probe. Shows the devices. Pick a device apparently. You select the device and apparently it has a voltage. Cool. So you can do a bunch of things. You can also do wireless signals, I think. That's apparently an item I can hold. I am holding creative tabs. Okay. Fuses I covered. These I covered. These are regulators. You can put them in this and these to regulate how they manipulate their temperature. There's also external control for these, I believe. So if you put them down, you can be like, oh, I really don't like any of that. I'm just going to hook up a signal wire to the back of them. I think you can put a signal wire on those sides. This side doesn't have a signal wire. This side takes the thermal cable. Electrical age doesn't add burnable items. Okay. Light bulbs. They're light bulbs. Some of them pull more power than others. Some of them last longer than others. Some of them have ranges longer than others. Overheating protection and voltage protection you can use for crafting, but you can also put them in batteries to prevent them from exploding. Combustion chamber, they go in the stone heat furnace. They make it more efficient. Cores I covered. Ingots, some of this is not useful. Some of this is not useful. Motors, these are used for crafting. This goes in a solar panel that can rotate. A multimeter can measure only certain things, so I'll grab these three just to show you what the differences are. So this one can measure the voltage, the amps, and the power. This one can only measure the temperature of the cable. And this one can measure all four. Congratulations, you know how the meters work. This thing that looks like a meter but has an antenna out of it is a wireless signal measurement tool. Can tell you what signals are in range and all that jazz. So I have wireless signals on the ground over here, and some of them are stronger than others. Especially over here, they should be powerful. Oops. So W-all, strength 64, pretty good. 64 is the number of blocks. Config copy tool, you can copy things. So you can just be like, oh, I see you have a device over here. I'm just going to copy it. Oops. That didn't actually do anything because this is empty. Good. Press shift and then right click. It'll make a noise like that. And then you can paste it by just regular right clicking. It'll set everything. Sometimes you have to replace the cable, I've discovered, and maybe click validate. Okay. That's that. Still work in progress, but you can copy some things. Drills, they drill different speeds, use different power, time per obturation changes. Ore scanners, you can scan for ores. It's a crafting recipe. Mining pipes are going to get cheaper. Tree resin you cook into rubber for cables. Copper cables. Do I have a crafting extension installed? No. Cables are used for different purposes. Graphite rods, you can put them together. These are things that may not stay. Brush colors, these are crafting materials, lots of crafting materials. You can put boosters in machines to make them run faster. Crafting materials. These are the things for the shooting things. This is a wrench. Apparently you can just be like, okay, I'm also going to just use this. I didn't right click, I left clicked. Dielectrics, these are useful with redstone in capacitors. Casing. Let's say I have some outdoor thingamabobbers. You can just pop them in there. And they look cool, and you can look at them and all that good stuff. You can just click on the top of them even if they have the casing on them. Yep, ta-da! Now they're all nice and boxed up and weather ready. I've already covered these. Flashlight does exactly what it sounds like. It's very similar to the one mod that I have that does dynamic lighting. So let's say I grab some batteries. And I grab a flashlight and some other tools. Oops. So these will actually charge off of, you know, just the capacitor pack just completely emptied. You can also charge them in here, but they don't have a whole lot of charge stored in them. But that will increase those. Capacitors charge pretty darn fast. They also discharge really fast, but good for powering things up, I guess. Okay. Flashlight. It's pretty simple. Oh, look, it's dark around here. No big deal. I just walk around with my flashlight. Heard you wanted to drill through things. Heard you wanted to cut down trees. Don't really have any trees or anything to cut down. Batteries and capacitors. Batteries are slow but hold a lot of power. And capacitors are fast, but they don't hold a lot of power. Or a scanner can just tell you what's in the ground. There we go. And I don't know what its deal is, but it's not finding ore very well. Apparently there's something good here. And hitting things with it will harm it, as you can see. It's not really working very good anymore. Fuel burners, those are for the thing up there. Armor. This is armor that requires power. It's kind of cool. So you just have batteries, and your armor doesn't take hit points. Your batteries just discharge. I think it's used crafting uses coal. And that's pretty much everything in a nutshell. Didn't intend to do that, but I guess it did. There's a couple of things that are disabled right now. Modbus RTU basically uses raw TCP to communicate with equipment or other programs. It's actually used... I don't really have a whole lot of information on it, but it's actually used in teaching of college courses, apparently. That's actually why Electrical Age was made primarily, is, from my understanding, is that someone wanted to use it to teach students how electrical circuits work. And at its most basic, it kind of achieves that. You know, I can have a basic circuit with... So we have creative cables, so those could actually kind of display this a little better, because there's going to be a lot of current if I do this. 40 amps of power. So this has resistance, obviously. You could actually determine what the resistance is just with that. That would pretty much explode any normal wire. Actually, it might work with this one. Yeah, solid. These go up to 20 amps. And you can see they definitely act like a resistor. You have Nixie's free energy. Just looking at the YouTube comments. Indeed. And kind of to extend that other comment about it being useful for teaching people things. Wrong thing here. Let's remove all of this. actually put a wire here, that will actually become a line. Let me just change this out for a moment, put this in here, and then put this wire back. I closed all of it. I'll go back and grab it. Okay. Minecraft and another one for my regular folder. This can actually be used as a really cool educational tool, I think. So you can copy this in over to here, replace. Actually, I'm going to do something enhanced. I'm going to make a link. Ta-da! It's a link. I think I actually just made a hard link too. Feature. Anyway. So now I think I can just make it easy enough for me where I can just do that. Now it's a line, resistor, and a line. And line is basically a compressed grouping of resistors. So no matter how long this is, it's just going to be line. It'll just change the resistance. If I do this, it might actually just not be a... I'm wondering if that link is working. Let me try deleting this whole thing. Delete this. I see a village over there. Oh, you know what I didn't do? Ruin matrix. Oh, because there's nothing in there. It just fails. Okay, so I'll put this down again. Put this in here. Set this to 2000. Set this to a voltage. Matrix. There we go. Nice little system. Yeah, and I think if you just remove this, it's still technically a subsystem. Just doesn't go anywhere anymore. Okay. And I can make this parallel circuit just by doing this. I'm going to move this here just to make sure that it doesn't do anything special. Okay. Yep, now it's a parallel circuit. You'll notice, oh, sorry about the microphone. There's so you have it come in. This actually became an electrical connection because it's really short wire, but these became line because they're longer. You have the two resistors, and then you have the two lines going back, so that's these, and then you have this connection here, and then the voltage source. Cool, right? I'd love to actually make this a little bit more fun. For sure. There's another, you can actually run this simulator here standalone from another repo on my GitHub. think it's this one. Yep. You can literally just standalone run the thing. I kind of separated it from the Minecraft code so you can just run it. Do it the easy way this time. I don't have IDE installed. I can't actually run this, but if you have an IDE installed, you can actually just build that and run it. I don't actually have the source, the build tools available on this computer. I haven't installed them. Okay. So yeah, that's that. And this should be drawing twice as much current, so you can see that it splits evenly between them. And if I change the resistance on one of these, let me lower the current. If I change the resistance, so this one's 2, this one's 4, you'll notice that the current, current has changed. And clearly explosions are on in this world. Oh, I should do the clutch stuff. Let's see here. This, clutch. Here we go. So yeah, as I was talking about earlier, with whoops, not what I wanted. I want this. Oh, I forgot to talk about vertical shafts. So if you have joint hubs, you can do this. Zoop. This won't place because you don't actually have something to place it on, but if you put a block there, you'll notice it even builds little anchor points where it can. You can put that up there. Ta-da! Okay, so I have that, and I'm just going to demonstrate all the features of this thing that I didn't get to talk about. So, let's explode some stuff. First off, we're going to put this down with some power in it. All that. Let's try again. And this is why this is a test world. Let's try a proper voltage this time. Okay, so this will explode. Oh, right, I need a, let me get this up to speed. Oops. Yeah, it'll also tell you speed. That's a weird feature of that, I guess. Make this a little easier on myself. I need a signal, so I need a button. Alright. Yep, that's to be expected. That's to be expected. So that's that. And then let's say that we want to take this out. That'll continue to spin. If I change the speed of this, it won't be connected anymore though. So you'll see this is still going 7, this is going 840. And then, you know, if I decide that I'm gonna just, you know, equip this thing with I'm blind again. Here it is. We should probably add a config for this feature. You just explode shafts. And this is still running, so this will explode too. This will not. This will. That probably will. We never got this one rotating, did we? So this is fine because it's not going fast. And also, if you have something that's not growing real fast anyway, so like say I have 100 volts here, it's like, oh look, it's going, you know, 20. You can place on that. Because because there's not enough, like, I think it's up to 230 you can do it. 100, yeah, it's totally fine with this. But if I put it up to like, you know, 270, so that it's just going to be an explosion. You can remove things just fine. You can delete it from the shaft, but if you're trying to forget it. Oh, now see it's below the speed that mattered, and it actually doesn't matter anymore. Explodey, explodey, explodey. And this probably isn't all that great for the network. But look, you can just be like, yay, I'm going to have fun and place things everywhere and consume CPU time because that's what these do. Little explodey bits. And these will probably explode in the air too. Just grab one of these. Oh, I already have one. That sounds fun. And apparently that can happen.
Happy birthday, bug your dad.
I think the explosion size changes how much it's rotating. And doing this definitely slows the shaft down too, by the way. Shaft networks. They're explodey. I don't think I've left anything besides this wire on the ground. And these will be separate networks. Average subsystem size 0. That tells you about everything you need to know. There'll be a second subsystem. It'll be very plain. Oh wait, no, there isn't. Huh? Oh, because this has a resistor in it. This actually won't show up at all. Ta-da! Anything else I should cover? I'll cover T2s real quick. Fun fact, on multiplayer servers, you can see through the bottom of these things only to actually, you can see it's error. Yeah, this will actually tell you what it is, and you can pick it. Okay. I'm gonna grab one of these, and I'm gonna show how these can be a bit on the explodey side as well. Although it won't actually explode anything. So let's say I have this, and this, and I'm gonna have this and this. I'm gonna have this. I need some cables. Connect these together, connect this to that. There we go. And then I'm like, okay, I got my, T2s going. Oh yeah, this is fantastic. Everything's great. Look at that. Voltages are fantastic. And then I'm like, okay, I'm going to go, a couple hundred blocks away, and I got my cables. I'm very happy. And then I'm like, all right, it's time to place down my other transformer at my remote location, middle of absolute nowhere. And I got my pole connected, and I'm like, all right, my grid's ready, and I have some basic, I'm not even gonna have a load. I'm just gonna be like, I'm gonna connect this live. There was a bit of current that went through that, and it actually exploded everything back at my home base. So now I have to walk back 1,000 miles and go like, okay, I broke everything. So that's why all of that current limiting stuff on the ingress side and connecting these T1s is so important over here. Because you can't connect and charge these transformers, even with no load. You can't charge these transformers off of these poles. You have to have a charge circuit like this. Hopefully we will remove the problem that causes that in a future release, which is basically these poles have capacitance, way too much of it. They should have some capacitance, but they have excessive amounts, which is not good. That's about all I got. Apparently it's 2 a.m. on my local time. Means I've been streaming for... It's only been 2 hours and 40 minutes. Minus some time for setting up. I hope my audio is okay. I'm gonna go fetch one of the older maps. Close this. Grab Firefox again. I'll go to our website. These images are a bit old, to be honest. But we got like a downloads page which tells you how to get all this stuff. So you can grab, this should be the latest, but it's not right now. You can go to files though, and you can see, yeah, latest was in January 23rd. January 23rd is actually LLV11. LLV11A, 1.A is actually what I'm using right now. And older versions of the pack, and also these are versions of Electrical Age here too. Whenever I changed mods and or Electrical Age versions, I changed the version number on the pack, and these are just kind of like bug fixes we're doing. And on a large server, you can actually start to see, this is a folder of all of the circuits for a world I'm about to grab. So if you go to worlds, you can actually grab some of the old dev servers. And I can grab, this one is the one I want. Yes, okay. Copy this into your Minecraft folder, saves. I just exploded that one, and we'll go over here, world, full screen. Ta-da! Whatever. Yes, please. Yeah, the TPS is pretty bad on this one. But this was the old server world, which is what all the screenshots on this website are from. In fact, we have some photos of various things we took that are visually pleasing. So yeah, basically in this direction, a lot of stuff we didn't actually really get around to finishing, but basically we had some plans over here. This was actually where I did some bug testing too. You'll notice that we no longer have a problem with cables being gray when it's grass. But now we have green sides because it turns out Minecraft's code for rendering blocks like this is jank at best. This is a collection of some bugs and things we wanted to add, so like the signal cable bug. You know, electrical meters aren't exactly as useful as they could be because now I'm running my meter backward. You know, it'd be nice if I could, you know, have a desk lamp. Currently, these can only be placed in one direction. Just weird bugs like that. I think the blue will always be on this side no matter how I place it. And then we wanted to do something like inductor sharing for inductors that are close together. Because magnetism Some other example stuff we have. So there's like this library here, which is completely solar powered and uses, of all things, a bunch of flywheels. It's down here on the lower level. It actually uses just flywheels to store power. Unfortunately, it looks like it's spanned down, but I think I'm going to blame world load on that one. This is a big test load. So right here you'll notice 0 power. If I connect this, oh, this isn't on. Is this actually? No, it's not. Okay. Remember that capacitance problem I was talking about? This is just charging these poles and charging these as well. And eventually it will just level off. Fun, right? Another big test load. Oh, this was the Schmidt trigger thing I was talking about. So basically when I played with them, I figured out what the trigger point of a signal relay versus a Schmidt trigger was. And these are the results. Looks like that. They're very similar. They click on almost the same time. But the actual thresholds are these. This is like some other fun things. More fun things with those. This is a good example of a build with combustion. And this is also, you can see how you have a cold side which tries to stay around 20C, and then a hot side which tries to stay warm, so that when you actually need to pull power, let's say that I want to throw some, you know, iron in here, these things will warm up. It'll warm this side a little bit. You want this to stay as cold as possible though, and it'll produce power. Dishes, thing we wanted. This was an efficiency test between steam being heated with a liquid fueled firebox versus using a gas turbine. I don't trust the results, but apparently it was a thing. Don't know what this is. This is another one of those variable voltage things that I was using with this to create voltages over here. Wayla is not working properly on this server. Oh, that's because it's running locally. Feature. So we have our test loads. Let's see if this thing's settled out. I actually want to look at the generator. You can see it loading in a little bit over here. Nice big generator, steam powered, uses a PID, very complicated PID. Well, it's not very complicated. You could probably figure out how it works if you play with it a little bit. But basically, we have a bunch of signal processors on the back wall here. This is where all the interesting stuff here is. So you can see the equation at the top there. And then this right here just sets the voltage. So it's 3.35 out of 4 kilowatts. And this is, I don't know, oh, this is setting the decimal point, so that the decimal point's here. This right here is just adjusting inputs. I think it's just doing the button. It looks like an AND gate, literally, actually. Something just exploded. I don't know what it is. Oh, looks like this finally exploded. This is a fun one. Totally survival possible. It runs a generator. Apparently that's not done exploding. Which powers these electrical age energy exporters, which pumps water and uses MineChem to split the hydrogen and oxygen discards the oxygen into this void chest set down here, and then burns said hydrogen to make steam so that it can run the steam turbine. And this is totally a resource loop. Also another little substation here. Yep, that's a pretty good one. These are when we were testing the load of these, how heavy you can load them. Here's another one. You can see this will be producing around 32 kilowatts. So you can do 16 kilowatts maximum on these without having too much trouble. That's how much these are at as well, full bore. This is another big generator. Also has my flywheel test. Oh, fun thing with the clutches. You can incrementally increase the voltage, like 1 volt, for example, and it'll do very small amounts of clutching. Instead of just being like, okay, I want this to engage fully, you can just engage it by a percentage. Couple different designs, self-starting design, some older designs that probably don't work in newer versions of Electrical Age. That's most of that stuff over there that I covered, all that on that side. So now we're going to go over here. There are some builds over here, like there's a couple more generators, but I'll leave that as an exercise to the user. The rest of this world is basically builds. So we have this building here, which is just a ton of lights, and it has a rotary power storage system, so that basically at night it uses power that it's saved up in a flywheel. So it saves power in this flywheel here. These generators go out to the actual building lights, and these motors here are powered by, this one comes from the grid, and these two come from the solar on the roof. This can all be monitored upstairs in this room, where you can see the solar voltage on the roof, how much power, what the grid looks like, how much power we're pulling from that, and then the output voltage for the lighting system, which is incredibly stable. Yeah, this is like a town hall. It's got like, you know, little meeting rooms. It's all using chisel. But it's just an example of what you can use Electrical Age to, you know, make things look really nice instead of using torches everywhere. And, you know, you can switch these lights on and off if you cared. I didn't actually really set up any of these to be configured to be turned off. But, you know, little nooks, crannies. You know, like a little eating area up on the top here. Entertaining. You know, you can hang out with people. Standing tables, sitting benches, sitting tables. You know, just hang out in the corner. Some more standing tables over there. Little things here and there. Transformer. This is grid B. Comes in from the side. So this building can actually take 2 different grids in, similar to the other server. So this grid here is completely separate from this grid here. And you'll notice there's like a big substation here. This generator right here theoretically could get up to around 256 kilowatts. I don't know that I've ever been able to test it that hard, but it's got a lot of dials and doohickeys and things. And this is another really good example of SigBus, and also this area is really saturated with wireless signals. If I just take one click at this space, you'll notice it's wireless signals for days. Because all of these are wireless signals. There's wireless signals on the roof. Every facet of this thing is measured and recorded on all these data loggers. Every single group of generators has its own current and voltage measurements. And it's a 2-feed system, so everything's here is colored. It's red or green. The starter is the same deal. It has a red starter and a green starter. Uses steam and gas for power. And this is the control circuitry for the gas and steam. And then this back here is a big adder, which basically adds together how many kilowatts of power. Or actually, this is amps, so you have to multiply it by volts, which is over here. So this is the voltage, and this is the amperage. So 20 times 3.3, that's some number. Yep, that's pretty much that. Some more unfinished builds over here. This building here is another good example. This someone was asking about a rotary, like a dimmer, and this kind of does that. So this is rotating around 755 rad per second, and power goes into this building here on the side. So I'll go inside and show you what the inside looks like. So it's like a movie theater. Hopefully the bulbs are good in here. Oh, they are. Perfect. It's got an open computer screen. So you'll notice that in the back here, I can also turn on these lights. I think one of these sets the lights for the lobby. Maybe not. Anyway, so this right here can be used to dim the theater. Also, I'm using those projector lamps from earlier to light the middle aisle, which is kind of cool, because the middle aisle, there's no convenient spot to put the lights. So this will slowly dim out the lights, although you can definitely use other methods to use as a dimmer. Basically, it achieves this by lowering the speed of the shaft outside until you actually bring the the lights all the way out. So that's kind of cool. So yeah, you can dim the lights in your theater. This took way too long to build. It was mostly building all these micro block seats. And so now the brightness is all the way down again. I think it's got a little more to go, but I'm going to turn the brightness back up in this room. So you just press the button again, and it'll spin the generator up, and it'll lighten this room up again. I think on older versions of Electrical Age, the dimmer works a little bit better, particularly the design before we implemented shaft motors, which kind of brought the efficiency to sane levels. Because originally it was all generators, and generators were as efficient at generating as they were at other things, and it was kind of broken. So yeah, it'll bring the brightness of this room up a little bit, and that'll be cool. Some of these houses have lights in them, pretty standard. So yeah, that's that shaft thing that generates the lights in there. This building here has a ton of lights. I don't think I've seen this many lights in any other building in Electrical Age. This person literally covered every facet of this building with lights, and it uses so much power that we had to have multiple panels down here for how many lights there are. I think I cut the power at the front of the house. Let me go grab that. Yep. I might have actually just tripped as I walked away. Oh, still on. Okay, all the lights are on in this building. 3.54 kilowatts, so that's going to be like 8 kilowatts of just regular lights. These are LED lights, by the way. These aren't like the other lights, and there's, you know, plenty of signals down here. So that's covering all these here. Again, the wiring is, you know, you don't want to do this because it's going to slow down your world, but we had power problems, especially here. You can see we have the Hexorian cooling cables. So you'll see, especially this one, these cables are supposed to pop at like 100 Celsius, but when I turn on the roof lights, it's so much power that it dims. This cable should be exploding, but it's actually just fine. It's just going to heat up, and it's going to heat up this pile here. but this will pull like 26, 27 amps. And that's all being spent. How much current is that again? I have a universal meter. That uses about 16 kilowatts of power, and you'll notice it even dimmed all the lights on the grid because the grid took a moment to actually power it up. All of that light is literally this one thing of farming lights on the roof. Each of these uses 120 watts, and there's this many of them, so compare that to this building full of LED lights on every single wall, and you'll see that there is definitely some power here. And the lights in the building will try to pull from the closest light source there is, so this one gets the most because it's the most central to the building. Turn off the roof. I think that's someone's PID generator going really wonky, actually, versus anything else. So yeah, I actually terraformed the world a little bit here. I did this by hand with the world edit. Took days. But you can kind of get an idea of how Electrical Age would look in a survival world. Some more micro blocks, a little train track. I made a little example here of what a mountain might look like. This right here is a good example of how you would set up some water turbines, actually. They don't make a lot of power, that's 30 watts per. Like, why would you ever want to use that? Wind turbines, which are on the top of this mountain here that I built by hand, is much the same way. They generate 15 watts each. Yeah, they should really have a lot more power. Just to prove that I made these mountains by hand, I actually left parts of them hollow when I was using the brush tool because I got lazy. So there's actually, and then there's another section over here that's also hollow. Yep, all by hand. Trying to see if there's anything else I should cover. Here's what a typical little substation looks like, by the way. It's just got a little pole here, comes down, and this was charged by hand using a solar panel or something. And then this right here just protects the wiring from blowing up, and that runs to all those wind turbines on the top of the mountain here. And then this goes that way. These cables down here don't actually do much of anything. They're just there for looks, pretty much. Another water turbine here, just to get a feel for how they work. Wind turbines work best at 100 for the Y level or higher. This is the substation for the roof of that house because it draws too much power. I used to work in a lamp store. I've never seen this many lamps. Neither have I. Yeah, I see in the comments someone says that PID is hard. Yeah, I don't know how to do it either. I don't usually use PID. I guess this is done exploding. But this system here totally uses PID. It also uses wire colors all over the place in the design. So you'll see different wire colors through here and SigBus on here. So there's a couple different buses. I would love to color these things, but we currently don't color them. You can't color them, it doesn't work. Or an exercise to the user, I suppose. Heck, I'll go over here. These generators use PID, last I recall. This is an interesting design. It has one power pole in the middle, and generators all to the side. And the interesting thing about these is that I think this was in the process of a redesign, but basically the starter was here, would start a small gas turbine with one generator. That one turbine with one generator would get up to speed. As soon as it's up to speed, it starts spinning up this row here. Once this row is spun up, it spins up this row. Once this row is spun up, it spins up this row. And then once this row is spun up, it runs this row. Goes all the way around in a big loop and actually gets everything up to speed. It's really cool, in my opinion. Looks like some other partially constructed ones, some power sinks, things like that. Oh, and this was just playing with the balance of motors and seeing how much current they use. And this right here was to prove a point that you could power this light for a long period of time off of just these flywheels. You can watch the energy slowly go down. But for the amount of energy I just put in like that, I mean, flywheels do store a lot of energy, kind of like a battery. Although you have to balance the speed of the shaft into the equation because it lowers the voltage coming out of this generator. But if you can make that work, and maybe you have like a bunch of DC-DC converters that actually upconvert, or if you use like a rotary converter for larger loads, you can totally make it work. Some other random designs. Some of these are bad, really bad. This one was okay before the update, but I don't know how it is now in LLV 11. Much of this was built in LLV 7, this stuff right here especially. And this was my little original load, or original generator design from like a year ago. Still going strong. Little happy generator. Anything else I want to look at? This is the spawn house. It has the original list of people that came on and some batteries for the lights in the building. Completely powered by solar. It's on the roof here, and they're running down inside the building, kind of hidden. Actually, no, they're not. They're just in the glass. So the fun fact: you can just take any block. Most blocks, not any block. Press C, right click. Wait, no, not right click. I think it's shift. I thought it was C. We might have broken that. Should be able to put cables. Let me just grab this real quick, I guess. Oops. Yeah, maybe that's broken. I'll have to look into it. Oh, I never put the test load on this thing. These things are up to speed, right? Yeah, I'm gonna assume they are. 20, 30, 40, 50, 60, 70, 80, 90, well over 90, well over 120, which is as high as this can measure, and then it's going to drop down. So it's going to do like a really, really slow sine wave based on the way the grid works because the capacitance, and eventually it'll stop ringing and it'll level out around, I think, 80 kilowatts, 90 kilowatts. And you can see the long-term rings better on the top chart than the bottom chart. Yeah, it'll level out around 80, I think. And that's outputting think that's that much RF. We used to have a mod that you could measure RF on. I don't know if any of these work on that. Exploded. I think that covers this world. No comments. Yep, I think I'm gonna wrap it up. Until next time. But yeah, that software's on my GitHub. It's good stuff. If you have questions on how to run it, let me know. You can poke us in the Electrical Age Discord. Bye.